online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So I am welcoming you all to this beautiful online learning platform once again. We are happy to announce that now Unacademy is going to providing online training for GATE and engineering service exams. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE examination. At present I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now first we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy. By typing Unacademy, it will show the Unacademy learning app like this. Just by clicking on this install button, it will install the Unacademy learning app into your device. Now what you will get? So by joining this Unacademy, what you will get? Now we check it. First and foremost thing is daily live classes. After that structured courses, and next one is live tests and quizzes. Last but not least, unlimited access. See here, now in daily live classes, so you can chat with your educator once class is going on, and you can engage in discussions, and you can ask your doubts, and sorry, and you can ask your doubts, and you can answer the polls. You can do all these things while class is going on. And after that, structured courses. So all our courses are structured in line with your exam syllabus to help you best to prepare for it. Whatever the courses here we have, all the courses are well structured with your exam syllabus. It means what are the different subjects you have in your course, all are arranged in a proper order and with your respective syllabus. First, which subject has to prepare, after that which one, after that which one. There is a sequence is required. That is very much important while preparing. So that thing we will perform here, as well as live tests and quizzes. So once your preparation is completed, you need to write more number of exams in that, and you need to regularly write the examinations, tests and quizzes you need to attempt, okay, to evaluate your preparation. So for that we are going to conducting regular mock tests and quizzes. Okay, with our regular mock tests and quizzes, you can evaluate your preparation, and after writing the tests, we are going to provide a detailed analysis on your performance. Next, unlimited access. So once you take in a one subscription, you can get access to all our live and recorded courses. And you can watch from the comfort of any of your devices. So you can get here live classes as well as recorded classes, and at the same time you can watch any of your comfortable device. Okay, now there are two subscriptions, iconic subscription as well as plus subscription. Two subscriptions. In plus subscription, what are the things? Just before I explained daily live classes, structured courses, live tests and quizzes, and unlimited access. All these things you get by taking this plus subscription. Okay, next. Now we are going to problems on FET amplifiers. Okay, this is our today's topic. Now, so the first one, what is the relation between V1 and V2 in this circuit? See, to get the relation between V1 and V2, first these two capacitors should be short circuit. Then only V1, you get V1 and V2. Okay, so first, to short circuit capacitors you need to do the AC analysis. Now first I am going to taking the AC equivalent circuit of this. AC equivalent circuit of this. Okay. Now first I am taking that AC equivalent circuit. So for AC equivalent circuit, we know that what we have to do. Capacitors are short circuited. All capacitors are short circuited. Okay. After that, DC supply connected to ground. That is the AC equivalent circuit. After performing all these things, your circuit is like this. This. Now, do one thing. First, I am taking the circuit. I am copying this part. Yes. Now, so to get the AC equivalent, all these capacitors should be short circuit, external capacitors, and DC supply connected to ground. So once we connected this one to ground, now the equivalent circuit is, this is going to be our drain. Here it is connected to ground. This is going to be output voltage. Sorry, V1. Then they mentioned it as V1. And this is RD. This is they given it as RD by 2. And this is the voltage V2. Okay. So this is the source terminal. This is the drain terminal. Now, this is the drain current ID. The source current it is. But we know that source current is equal to drain current. This is ID, but this is minus ID. From this we can write V1 is minus ID into capital RD. From this we can write V2 value. V2 is IS into RD by 2. Capital RD by 2. But IS is nothing but a ID. IS is ID. ID into RD by 2. Now, this ID into RD can be written as minus V1. This is our V2. So therefore V2 is minus V1 by 2. V1 equal to minus 2V2. This is the relation between V1 and V2. V1 equal to minus 2V2. So V1 equal to V2, V1 is 2V2, V1 is minus V2, V1 is minus 2V2. Yeah, this is your option. Option is D. Okay. Next one. In the FET amplifier, shown in the figure, the approximate voltage gain of the amplifier is, so they want voltage gain, they given GM value as well as RD value, small RD. Okay, first of all you need to identify the circuit is belongs to which type of amplifier. That is very important thing. Okay, so the circuit is a, see, drain connected here, and this is the source connected to ground, because it is a n channel JFET. Okay, so in n channel JFET, source is connected to ground, drain connected to supply. So therefore it is common source amplifier. First of all, it is a common source CS amplifier. That is the first point. So once it is CS amplifier, common source amplifier, then we go for its voltage gain. So voltage gain of common source amplifier is minus, so it is a common source amplifier. So it is minus GM into small RD parallel with capital RD. Load is 10 RD. This is your RD, sir, capital RD. This is the equation for voltage gain. Now just substituting the value. Minus GM minus 1 milli 10 power minus 3 into small RD 100k parallel with 10k. Now it is just calculating this 1000 by 110. It is a 9 to 1 9, so it is a minus 9.09. That is the voltage gain. That is the voltage gain. See, very simple. So already we analyzed this common drain amplifier, common source amplifier, and common gate amplifier. From that knowledge, I am going to using the relations. Okay, so my sincere request is, if necessary, then only go and replace your MOSFET or FET by its approximate, by its small signal equivalent. Otherwise, don't go for that. Okay, practice these formulas, standard formulas, gain, impedances, gain, okay, all these things. Now, see this next one is calculate the voltage gain AV VI by V0. Sorry, it is a V0 by VI, sir. V0 by VI by mistake. Calculate this voltage gain V0 by VI at 1 kilohertz for the circuit shown. Given transconductance is 2 milliamps per volt and RD is 10 kilovolts. See, in this problem you observed or not, at a specific frequency they are asking the gain. At a specific frequency they are asking the gain. So to answer this, you should know the frequency response of this. So 1 kilohertz frequency is, in general, it is a low frequency. Now if you observe the frequency response of this amplifier, it is like this. It is the generalized frequency response of an amplifier. Okay, and this is called the maximum gain, AVM, maximum voltage gain. This is a 3 dB frequency, and lower cutoff frequency and a higher cutoff frequency. Okay, now so lower cutoff frequency means it is going to be close to this approximately. First you need to calculate AVM. After that, at a particular frequency, the voltage gain, the magnitude of voltage gain at a specific frequency is AVM, maximum voltage gain, by square root of 1 plus FL by F whole square. If the frequency AVL, if the frequency is close to lower cutoff frequency, frequency is close to higher cutoff frequency, the gain is AVH, magnitude is mod AVM, maximum voltage gain, by square root of 1 plus F by FH whole square. Okay, so to identify this F is this 1 kilohertz is close to lower cutoff frequency, higher cutoff frequency, first you should know that value. So higher cutoff frequency is not in our hands. Most of the cases it depends on the device parameters. That means designing of the fabrication of the device. Okay, and now external capacitor they given. Based on this, we can identify the equation of lower cutoff frequency. Okay, and if you take the small signal equivalent of this, now I am copying the circuit to get the small signal equivalent. Yeah. Now I am taking the small signal equivalent of this. So by taking small signal equivalent, it is like this. Only I am taking output part because I want. So output side, it is a GM-VGS. Here is a small RD. It is the drain. And at drain to ground, we have 50 kHz. It is 50 kHz. Sorry, 50 kilo ohms. Sorry, 50 kilo ohms resistor. And after that, the most important thing, here we have a capacitor. That is 0.3 microfarad. After that, here we have 50 kHz, another 50 kilo ohms. Sorry, 50 kilo ohms. Okay, and they given the RD value, which is 10 kilo ohms. 10 kilo ohms. It is 10 kilo ohms. Now, its frequency, the cutoff frequency due to this external biasing capacitor is lower cutoff frequency. Now its value is 1 by 2 pi RC, simple. That is the capacitance value. Here C value is 0.3 microfarads, and R value is, so to calculate the, just to calculate the resistance in this direction, that is your R value. So for that, current source is open circuited, these two are parallel, and this parallel combination is series with this. So R is 50k plus 10 kilo ohms parallel with 50 kilo ohms. So now it is 10k parallel with 50k, 500 by 60, 8.33 kilo ohms. So now it is 58.33 kilo ohms. 58.33 kilo ohms. Now go and calculate FL value, lower cutoff frequency is 1 by 2 pi into RC. R is 58.33 kilo, 10 power 3. 10 power 3 into C, 0.3 micro, 10 power minus 6. H. Okay, that is the frequency. Now I'm going to simplify this. Yeah, simplifying this, therefore it is 1 by 2 into 0.3, 0.6 divided by pi. So it is 0.3 divided by 0.6 is 0.53, 0.53 divided by, this is this one and this one, divided by 58.33 into 10 power 3. divided by 0.53 divided by 58.33. Yeah, it is 9.08 into 10 power minus 3 into 10 power 3 h, that is 9h, 9.08 h, that is the frequency. Okay, so there is one thing, just a minute. 50. So actually 50. Okay, so this is a 9h, approximately 9h. At this point we need it, we need a gain. First of all, you need AVM, maximum voltage gain. So AVM value is minus, it is common source amplifier, so minus GM into small rd parallel with RL dash. So where RL dash is 50k parallel with 50k, that is 25k. Therefore gain is minus GM value 2 milliamps per volt, it is 10k, minus 2 milliamperes, 10 power minus 3 amps per volt, RD 10k parallel with 25k. So which is 250 by 35, 7.122, that is 14.2, 14.28 minus, that is the gain. Now at 1 kilohertz we need the gain. So now at a, therefore voltage gain at 1 kilohertz is 1 kilohertz is mod AVM by magnitude only I want here, square root of 1 plus FL by F whole square. So that is previous we got 14.28, 14.28 by square root of 1 plus FL is 1000 divided by 9 whole square. So it is 1000 by 9. See, approximately you can take it as a approximate value I am taking. So it is 10 approximately. You can assume approximately 10 it is. You can take approximately 10. 10 it is 0. 100 square is much greater compared to 1. So we can neglect that. Square and this one cancel by 100. So your gain is 0.14 approximately. So gain is very low because the frequency plot is like this. Like this. So this is the maximum gain. Okay, and lower cutoff frequency we got edges. Okay, this is the maximum gain. So this is the gain at that particular frequency. Okay, so after that so next problem, see this next problem. So they given a common source amplifier. So for common source amplifier, so for common source amplifier, calculate the voltage gain and input resistance. Input resistance. See, it is common source amplifier. Default, we know the voltage gain. So voltage gain of this is given clearly, it is common source. it is minus gm into small rd parallel with capital RD value. This is capital RD. So they did not given GM value directly, they given RD or RDS, and mu value, amplification factor they given. So amplification factor mu is equal to GM into RD. So mu is 60 equal to GM into RDS. So now GM is 60 by it is 30. Okay. Therefore GM value is 2 milliamps per volt. Substitute here. Minus 2 milli 10 power minus 3 into small RD value 30k parallel with 3k it is. So now it is. So its value is 90 by 33. That is 2.72 into 2. That is 5.45 minus 5.45. Okay. So the impedance at this point is input impedance of the device, input impedance of the FET, which is infinity because of Ig0. Now this is the effective input impedance, and input impedance of the amplifier Ra dash, which is 10 mega parallel with mega ohms parallel with Ra, which is 10 mega ohms. This is the input impedance, and this is the voltage gain. So they are asking both voltage gain and input impedance they want. Now see, Unacademy combat is going on, and every Sunday of this month April, probably you can expect next month also, every Sunday there is a scholarship test. Don't miss that. And in that scholarship test, duration of the scholarship test is 60 minutes duration. Okay, and it will start on every Sunday on 11 a.m. In that, top 3 winners from each branch get 100% scholarship and plus subscription, and 100 winners from each branch will be given additional discounts. Okay, so these are the best things you get from the scholarship test. So it is the India's largest weekly scholarship test for GATE, and you can assess your GATE preparation in 60 minutes, and at the same time challenging and original GATE questions you are getting, which was curated by the best educators, and take it live to compete with the best, compared to the topper where you are. At the same time, super fast and fun with All India live leaderboard. All India live leaderboard. And identify and improve your weak areas through detailed video solutions. After completion of the exam, you get the in detailed video solutions of that. So through that, whatever the doubts you have in that questions what you are getting in your exam, if you have any doubts, you can clarify those doubts from the detailed video solution. Okay, and here are the GATE 2021 rankers who benefited from GATE combat. Next, see this. Now this is the common drain amplifier. So for this common drain amplifier, they are asking the voltage gain. Okay, so the voltage gain of common drain amplifier is voltage gain of common drain. It is CD, common drain amplifier is, this is RS, GM into RD parallel with RS divided by 1 plus GM into RD parallel with RS. This is the voltage gain. Okay, now just to substitute the values in this, not more than that, just substitute the values in that. Okay, now try yourself. just try yourself. So here RD they given 30 kilo ohms, RS 5 kilo ohms, and GM is you get from this similar way. GM is mu by RDS. So mu is 60, RDS I am calling it as RD. So that is 30k they given. So that is 2 milliamps per volt. 2 milliamps per volt. That is the value of it. Okay. Now just substitute the values in that, not more than that. Okay. Just substitute your values in that. Now so this voltage gain is my GM is 2 milli 10 power minus 3 into RD 30k parallel with 5k divided by 1 plus 2 into 10 power minus 3 into 30k parallel with 5k. Just simplify this. So that is 35 sorry 150 divided by 35, that is 4.28. okay, into 2, 4.28 into 2, that is 4.57. 4.57 divided by 1 plus 4.57. So 4 point, sorry it is 8.57. So 8.57 divided by 1 plus 8.57. So which is 8.57 divided by 9.57, that is 0.89. 0.89, that is the voltage gain. Okay, see, once you are thorough with the proper analysis of amplifier, what are the equations we have, you can directly apply that equations. If circuit is similar to your regular standard circuit, if there is any additional modifications in that, then you need to take the its equivalent model. Okay, replace your take the AC equivalent, replace FET by its small signal equivalent, and you need to do all those additional things. Now see in this, see here your gate terminal is connected to ground, gate is connected to ground. Okay, so once gate terminal is connected to ground, so this is a common gate amplifier. So this is a common gate amplifier, already they given the same. Given calculate voltage gain if GM is 2 into 10 power minus 3 amps per volt and RDS 30. Okay, so first you should know the voltage gain of common gate amplifier. Voltage gain of common gate amplifier. Okay, see, already we calculated the voltage gain of common gate amplifier. So the voltage gain of common gate amplifier is 1 plus GM into small rd into capital RD by small rd plus capital RD. Okay, that is the equation, exact equation for voltage gain. Okay, now directly substitute the values. So 1 plus GM value, they given it as 2 milli, 2 into 10 power minus 3 into RD 30k, 30 into 10 power 3 into capital RD. So this is your capital RD, it is your RS. Capital RD is 1 kilo ohm, 1 kilo ohm. So 1k. So 1 into 10 power minus 10 power 3 divided by small rd plus capital RD, 30k plus 1k. Simplify this. So now it is 1 plus 2 into 30, 60 divided by this k gets cancelled by 31. 61 by 31. That is the voltage gain. 61 by 31. So now get the value. 61 divided by 31. It is 1.96. 96. Okay. 1.96. That is the value. So like this you can solve the problems. Okay, now so next we go to next problem. Now see this. So in this they given, so the problem is calculate the voltage gain AV, calculate the voltage gain AV, and current gain also they want current gain also. They given this current is I naught, so you need to calculate voltage gain AV and current gain AI. For a given data, GM is 2 millisiemens amps per volt and RDS is 30 kilo ohms. That is the given data. Okay, see now this is the given, clearly it is a input current, this is the load current. Now current gain became output current by input current. What they given? Input current from this circuit. At the same time, voltage gain is required voltage gain is output voltage by input voltage. Output voltage by input voltage. Okay. Okay, now I'm going to follow in the regular procedure. And first of all, you observed or not, this is going to be your common source amplifier. Common source amplifier. Okay, now we know the values for common source amplifier. Directly you can substitute that values, it's not a problem. At the same time, we need to calculate current gain. So for that current gain we need to do additional thing. Okay, so I'm going to following the regular procedure. So in that I'm taking short circuiting all external capacitors, step 1. After that, DC supply connected to ground. Okay, by doing all this 800 kilo ohms plus 200 kilo ohms, both are parallel. Okay, now I'm going to take that. Now it's a small signal equivalent is at input side we have 5 kilo ohms, and here there is a voltage source, is a V input. So V input. At the same time, gate connected to ground through parallel combination of 800 was parallel with 200k. It is a 800k parallel with 200k. So this is gate, it is open circuited because gate current is 0. And after that, at a drain we have a current source like this, dependent current source, voltage dependent current source, GM VGS. After that, small RD. So now it is drain terminal, it is source terminal. source terminal. It is also your source. And drain to source, we have 2K parallel with 2K. This is 2 kilo ohms, and this is another 2 kilo ohms. Clearly they are saying it is output voltage, and this is your output current. Clearly they mentioned output current is flowing through 2 kilo ohms only. Okay, now, okay, so first I am going to calculating the output voltage. So we know that this is going to be the output voltage, fine. So here GM VGS is the current, okay, and GM they given 2 milli Siemens per volt. So what I am doing is I am going to converting this one into a this part into a current source to voltage source. Okay, just I am converting that one into a current source to voltage source. After that, the equivalent circuit is like this. This is the equivalent circuit, next level. It is 5 kilo ohms. After that, we have 800 parallel with the 200. So its value is 16,000 divided by 1000. That is 160 kilo ohms. It is the gate, it is the source. After converting that part into voltage source, now it is dependent voltage dependent voltage source. It became current is flowing this side, that's why it is positive, it is negative, and V is equal to IR. So its current is now GM into VGS into RD. That is GM they given 2 milli into RD 30, okay, into VGS. So it is a 60 VGS, the voltage source value. So it is a 60 VGS in series with RD. This is RD 30 kilo ohms. This is your RD. Now it is your drain, it is source. Just I converted whatever the dependent current source, voltage dependent current source at output side, I converted that one into a voltage source. And between drain to source we have already 2 kilo ohms parallel with 2 kilo ohms. Parallel with 2 kilo ohms. Okay, this is 2K and it is 2 kilo ohms. Now the current through this one is I0, don't forget that, and this is your output voltage. Now I am writing the equation for output voltage. Just both are parallel, so this is also output voltage. Just apply voltage division. Therefore output voltage can be written as voltage source minus 60 into 60 VGS into 2K parallel with 2K divided by 2K parallel with 2K plus small rd 30K. Directly I am substituting the value 30K. Just to simplify this, 2K parallel with 2K, it is 1K, okay, and it is 1K, 31K. So minus 60 VGS by 31, okay, minus 60 VGS by 31, okay, that is the into VGS. This is your output voltage. So here is your VGS. Now we need to relate input and VGS. Now I am going to relating that. So first of all, now VGS is applying voltage division, V input into 160K by 160K plus 5K. So that is V input into 160 by 165, that is 0.969, so approximately 0.97. 0.97. Okay, so just substitute this VGS here. Therefore output voltage is minus 60 by 31 into 0.97 into V input. Therefore voltage gain AV is V0 by V input, which is minus 60 by 31 into 0.97. Okay, so 60 divided by 31 into 0.97, that is 1.87, minus 1.87, minus 1.87, that is the voltage gain. And in the problem they given, this is your input current II. Okay, so we need to calculate output voltage. For that I am copying the same, voltage gain we need to calculate. For that I am copying the same circuit. Now it is, see, so input current is, now just applying KVL to input loop. From this we get V input is II into 5K plus 160K. Therefore input current is V input by 165K, that is the input current. At the same time output voltage is V0 is I0 into 2 kilo ohms. Therefore I0 is V0 by 2K. So therefore we need current gain. Therefore current gain AI is output current by input current. Output current is V0 by 2K and input current is V input by 160K, 65K. Okay, therefore AI is 165 by 2 into V0 by Vi. So V0 by Vi is nothing but our voltage gain. Okay, and first of all its current voltage gain value is 1.87 into, it is 165 by 2, 82.5. Okay, into 1.87, that is 154.2. So it is minus, its value is minus 154.2. This is the current gain value. Generally we taken current gain is infinity for FET amplifiers, common drain and common source amplifiers. Okay, because clearly they mentioned, they given a biasing resistors also in this case, and input voltage source they given. Because of this biasing resistors and input voltage source, due to this source some input current is flowing in this loop. Okay, but this current is zero, no change in that. Okay, because of this some current gain we get. Okay, this is the problem. Now see the see this problem. Find the small signal model for the two parallel connected JFETs given in device are equivalent. Given the devices are equivalent. See this? So they taken two FETs, both are identical. Both are identical devices. Okay, both are equivalent devices. Identical. This is the gate 1 as well as gate 2. Both are shorted. This is a drain 1 and this is a drain 2. Both the drains are shorted. and this is source 1 and it is source 2. Both these sources are shorted. By combining, these two drains are shorted and they are calling it as a drain, and they are calling it as a source, and they are calling it as a gate. Okay, now just take the two FETs small signal equivalent first. So it is a first one, small RD. Okay, this is the device. Now we need to take the identical one. So let us take this is identical. Now here this is a gate 1, gate 1, it is gate 2, drain 1, drain 2, source 1, source 2. Okay, now both the gates are shorted. Both the gates are shorted and they are calling it as a gate. Both the gates are shorted and this is the gate, this gate. Next, both the drains are shorted. Both the drains are shorted and they are calling it as a drain, single drain. At the same time, both the sources also shorted. Both the sources also shorted. Now I am going to short circuiting both the sources. Sources are shorted like this. Okay, now if you observed it or not, it seems to be like this. Two things, two identical, two equal devices, both are parallel to each other, and the value of this one is, this is VGS1, this is VGS2. From this, VGS1 is nothing but a V. See, this is your VGS. G1 is nothing but a G2. S1 is nothing but a S2. Therefore, VGS1 is equal to VGS2. Now I am calling it as simply, and one more, they are calling it as simply source. Source, which is, take it as simply VGS. Now this current is written as simply, both are identical devices. That's why it is GM itself, GM into VGS as well as GM into VGS. GM into VGS. Okay, GM into VGS. Now you observed or not, this current is flowing from drain to source, as well as this is also flowing from drain to source. Now between drain to source, here we have one RD. Between drain to source, here we have another RD. Okay, now I am going to redraw these two. Now in this, now I am going to rearranging the circuit. Its equivalent is gate 1 and gate 2. I am calling it as a gate, single gate. So this is a single gate. Source 1, source 2, both are shorted. Now it is calling as a source and RD. Similarly, from D2 to S2, that means D2 is nothing but a drain, S2 is nothing but a source. Drain to source, we have another GM, VGS, RD. Now both the current sources are in same direction and both the resistors RD are in parallel. Now it is simply replaced by this circuit. Gate, source. Now it is 2 times GM-VGS, 2 times GM-VGS. So current value is double, resistance value is half RD by 2. RD by 2. Simple. That is the drain. And it is the drain current. This is VGS. This is the small signal equivalent of FETs. Two identical FETs are parallelly connected. Okay. Now, see this. So next problem is find the voltage gain V0 by Vi and current IL by II. So this is the load current. This is II. And output resistance R0. If GM is 25 milliamps per volt, Siemens in this sense, and RDS 25 kilo ohms. Okay. Simply, you observed or not, this is similar to the FET what we are using. Okay. Similar to the FET what we are using, but two identical FETs are connected parallel. So you can write the direct equations what we designed previously, what we use, but instead of GM use 2GM, instead of RD use RD by 2, small RD by 2. Okay. Now I am taking its small signal equivalent. So we input 5K, 100K. 5K, 100K. This is V input. Gate, source. Between source to gate we have a current 2 GM VGS. 2 GM VGS. Because both the FETs are identical and connected in parallel. And RD by 2, small RD by 2. So it is connected to drain and source. After that we have 2K parallel with 2K. K parallel with 2K. So here we are taking output and this is the output current, IL load current. So whatever the current source here we have, I am going to replacing this part of the current source by its equivalent voltage source. After converting that one into its equivalent voltage source, it became V input 5 kilo ohms, 100 kilo ohms, it is gate, minus plus this one into this one. So 2 gets cancelled, GM VGS into RD. So which is GM RD into VGS. And here it is RD. $2K and $2K. This is load current and here is output voltage. Okay, now I am going to copying this circuit to calculate voltage gain and current gain. So now it is RD. This is the load current IL. Here is output voltage. Now, so this is your input current IN. So from this we can write input voltage is input current into 5 kilo ohms plus 100 kilo ohms. So input is 105k into I input. At the same time, this is our VGS. Now we can write VGS is, by applying voltage division, V input into 100k by 100k plus 5k, 100k plus 5k. So that is 100 by 105. 0.95 V input. That is the VGS value. So VGS is 0.95 into V input. Now I am going to getting output voltage from this voltage source. Simply output voltage is, take it V out, minus GM into RD into VGS into 2K parallel with 2K by 2K parallel with 2K plus RD. Substitute values. GM minus 25 milli into RD 25k into VGS is 10 power minus 10 power 3k by into 1k 2k parallel with 2k, it is 1 kilo ohm by 1k plus RD 25, total 26k. This k and this one gets cancelled. This 10 power 3, 10 power minus 3 gets cancelled. Now 25 into 25, 625 divided by 26. That is 24 minus 24 VGS. Okay, so, and from one more here, from this we can write output is IL into 2 kilo ohms. Now we got output is minus 24 VGS. At the same time, our input is, we get VGS is 0.95 V input. VGS is 0.95 into V input. Substitute this one here. Therefore, V output equal to minus 24 into VGS 0.95 into V input. Therefore, voltage gain AV is V output by V input, which is minus 24 into 0.95, 25.26. That is the voltage gain. So next I am going to current gain. Before going to that, we know the input current, input voltage and output voltage. Just use that. So we know the input voltage. So input voltage is 105k into input current. Similarly, output voltage is 2k into I output. So IL, load current, there we have mentioned. Therefore, we can write IL by IN is V output by 2k divided by V input by 105k. So current gain is V output by V input, that is a voltage gain into 105 by 2. Okay, so this is a 52.5 into voltage gain minus 25.26, just to simplify, into 52.5. Yeah, it is a 13 minus 1326.3. Okay, that is the, sorry sir, it is current gain sir, it is current gain. Yeah, so that is the required value. Okay, they are asking that value. So you try yourself this problem, or simply apply the, first take the AC equivalent, after that okay, go to this. So first I am going to applying the AC equivalent. For AC equivalent, all external capacitors are short circuited. Once we short circuit it, no use of this, it is short circuiting, as well as it is also short circuiting. So after short circuiting all these things, its equivalent circuit is, and DC supply connected to ground, drain connected to ground, drain connected to ground. At source we have source, it is source connected to ground through 1.2 kilo ohms, 1.2 kilo ohms, and at the same time from source we are taking output resistance load RL is 1 kilo ohm. At the same time input side we are applying VI, and between gate to source we have 1 mega ohm, 1 mega ohm. It is acting as a now feedback resistor. This is the equivalent circuit at present. Now I'm going to replacing FET by its small signal equivalent, and after that I connect the additional things which are present in this. Now see this, I'm going to taking its AC equivalent circuit. So replacing FET by its small signal equivalent. First of all I'm starting from gate. So your gate, it is gate connected to ground through VI. After that from gate, okay, next I'm going to taking a source, it is source, drain, it is from drain it is GM VGS, it is RD, it is a drain. Now drain connected to ground, so source. Now from source to ground we have 1.2k parallel with 1k, and at 1k they are taking the output, and at the same time you observed or not, through 1k it is a load current IL. So it is 1.2 kilo ohms, and here we have 1k. So here we are taking output, it is the load current IR. This is VGS. And one more important thing, between gate to source we have 1 mega ohm feedback resistor. So here is 1 mega ohm. Okay, so we need to calculate voltage gain and current gain for this, and at the same time in this circuit they given it as input current. This is input current. Okay, now so just what I'm doing is I'm going to applying simply a voltage division. Okay, sorry, here see this, At this point I am going to apply KCL. Instead of voltage division, we go for a KCL. It is very easy to us. Let us take this current is I1 and this current is I2, and there is an input current coming from this side. Because this current is 0, so this current is coming like this. That is input current. Okay. Now, and one more thing, we know that it is ID, drain current. The same way it is also drain current. Okay, anyway, now at this point first I am going to apply KCL. So now it is a voltage at this point is nothing but a V0. So V0 by 1.2k, current is leaving, this current also leaving. Okay, so now it is V0 by 1.2k plus V0 by 1.1k plus, so these two currents are leaving, and these three current, this one and this one are entering. At the same time, you can take it as a okay ID also. After that we can divide that ID. Do one thing. Okay, these two are leaving and these three are entering. Sum of leaving current equal to sum of entering is sum of leaving. Now entering is input current plus GM VGS plus I2 into RD. So I2 is nothing but a voltage at this point minus voltage at this point. It is connected to ground. So 0 minus V0 by RD. 0 minus V0 by RD. Okay, this is the value. Okay, now at the same time your input current is voltage at this point minus voltage at this point, V0 by 1 mega. So I input also we know that, which is V input minus V output by 1 mega. Okay, and at the same time they given the RD value 30 kilo ohms. They given RD 30k, and additional things what they given, GM 22 millisiemens. So GM is 2 millisiemens or milliamps per volt. See, now substituting these things here, therefore V0 by 1.2k plus V0 by 1k, and this is minus V0 by RD, taking this one this side. So it is V0 by RD value 30k, and plus taking this in this input I am substituting Vi minus V0 by 1 mega. Now taking this one also this side, or V0 by 1 mega equal to V input by 1 mega plus GM into 2 milli into VGS, 2 milli into VGS. Okay, now 2 milli into VGS. Now what is the VGS value in this? Just by applying, this is the voltage VGS. You can write VGS is a voltage at gate V input minus voltage at source V0. V input minus V input minus V0. That is the VGS. Okay. So VGS is V input minus V0. Simple. Take this one and substitute here. And after that take that one also this side. By simplification, I'm taking this one to the next one. So substitute this one here. Therefore it is a V0 into 1 by 1.2. So V naught by K I am taking common, 10 power 3 common, plus 1 by 1 plus 1 by 30 plus 1 by 1000 is equal to Vi by 1 mega into plus 2 milli into VGS is Vi minus V naught. Add this 2 milli V naught also this side. Therefore V naught by 10 power 3 into 1 plus 1 by 1.2. So plus 1, that is 1.833 plus 1 by 30, 0.033. So compared to all these, you can neglect this 0.001 plus taking V naught common, already by K it is 2 V naught, so it is plus 2 is equal to here 2 Vi into 1 mega 1 by 1 mega plus 1 by 2 by K. Okay, now we can write this simply. It is Vi into Vi by 10 power 3 into 2 plus 0.001. So this 10 power 3, this 10 power 3 gets cancelled. Now just add this. Therefore it is V naught into 3.833 plus 0.033 plus 0.001, that is 3.867 is equal to 2.001 times Vi. Therefore voltage gain AV is V naught by V input. So now it is V naught by V input is 2.001 by 3.867. So this is 2.001 divided by 3.867, that is 0.51, 0.517. That is the voltage gain. So far we get the voltage gain. After that we need current gain. So to calculate current gain, first get the output voltage. They mentioned it is load current. Yeah, clearly they mentioned load current. Output voltage is IL into 1K. So output voltage is IL into 1K. At the same time input voltage is this is input current. I input into 1 mega plus voltage at this point is V naught plus V naught. Okay, now take these two equations. So output voltage is IL into 1K and input is In into 1 mega plus output voltage. Okay, now just divide both sides with respect to V input. By dividing that is 1, so there you get 2 unknowns. So we know that V naught. Okay, good. Now divide this one with respect to V naught both sides. Therefore V input by V naught equal to, okay, therefore this is output IL into 1K. Now I am dividing both sides with V input. So input voltage is this one, II into 1 mega plus V0. Okay, but V0 is IL into 1K. I am writing this. IL into 1K. Okay, now take this IL into 1K common. Now it is voltage gain V0 by Vi equal to IL into 1K by IL into 1K into 1 plus II by IL into 1 mega by 1K. 1 mega by 1K. Simplify this. Both will get cancelled. So from this 1 plus IL by II is, sorry, it is II by IL. So which is a 1 by AI. 1 by AI into 1K is equal to 1 by AV. From this 1 by AI equal to 1 by AV minus 1 divided by 1K. Therefore AI is 1000 by 1 by AV minus 1. 1000 by 1 by AV. So AV is 0.517. So 1 divided by 0.517. That is 1.93. 1.934 minus 1. So it is 1000 by 0.934. So 1000 divided by 0.934. That is 1070.6. That is the current gain. Okay, like this, from the given data you can calculate whatever the required data you want. Now here are the few of the top educators from Unacademy. Tiwari sir, he is the IIT topper and he has 7 years of GATE and engineering service teaching experience, and he is the author of the book GATE in 75 days. Next, Ankit Goyal sir, he is the obtained all India first rank twice in GATE electrical, and he was awarded President of India gold medal in IIT Indore. Next, Sanchit Jain sir, he is the computer science faculty and he is having teaching experience of more than 8 years. Jaspal Singh sir, he is the ex-IAS officer, he got all India 4th rank and he is a scientist, GATE state service exams PSU topper and ex-senior GATE ESE faculty. He has more than 12 years of experience. These are our top educators. Because of these things only we are claimed that our educators are top educators. So toppers in IIT, toppers from GATE and gold medalists, and toppers in IES and well experienced faculty. Here are few more top educators from Unacademy. Now these are the different engineering disciplines available in engineering service and GATE in Unacademy. Electronics and communication engineering. Next, chemical engineering. Next, mechanical engineering, computer science and IT departments, instrumentation engineering, and after that electrical engineering, next civil engineering, and last but not least production and industrial engineering. These are the different engineering disciplines available in Unacademy for GATE and engineering service examinations. For GATE and engineering service examinations. There are two subscriptions, plus subscription and iconic subscription. In plus subscription and iconic subscription, both the case, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Already I explained about these 4 at the beginning of this session. Now there is a difference between plus and iconic plan. Plus plan is the iconic plan, basic plan, and iconic plan. With iconic plan we will take your preparation to the next level by providing a personal coach. So whoever the personal coach we provided to you, now he is going to perform a detailed analysis on your exam paper. It means whatever the test you've written or live tests and quizzes you attempted, it was forwarded to your personal coach. Forwarded to your personal coach. He do the personalized test analysis on that because he's a top exam expert. And after analysis, they will prepare proper study planner to you and respect to study material based on that. For that, based on these two, by following these two, every student can get success in their examinations. That is the very important thing here. Next one is, there are two plans as you mentioned, plus plan and iconic plan. In plus plan there are different subscriptions: 1 month subscription, 3 month subscription, 6 month subscription, 1 year subscription, 1.5 year subscription, and 2 year subscription. Okay, and the beauty is, except this is only 1 month subscription. From here it is available in EMI option, equal monthly installment option is available. Okay, at the same time, for 1 month they are charging 30,000. For 1 year, if you observe, 30,250. And by using my code VRAW10 during subscription, you get it by 10% discount. You get it by 10% discount. Okay, at the same time, as a faculty, I recommend the students to take minimum of 1 year subscription. Minimum of 1 year subscription, because minimum 1 year subscription is required. Minimum 1 year preparation is required for you to complete the preparation of all your subjects, plus to write more number of exams in that, and to identify the gaps in your preparation, and to fulfill those gaps you need to spend minimum 1 year, sorry. Okay, that 1 year time is required for you. So I am suggesting, as a faculty, I am suggesting you, please take minimum of 1 year. Okay, and don't forget to use my code VRAW10 during subscription. Next, iconic plan. In iconic plan, only 2 subscriptions: 1 year subscription and 2 year subscription. For 1 year it is 50,250 rupees. By using my code VRAW10 during subscription, you get it by 10% discount. At the same time, here also EMI option is available. Okay, so this after 12 months for 1 year, by using my code you get it by 45,225 rupees only. 45,225 rupees only. Okay, so that is for 1 year. And don't forget, here you are getting a personal coach. You are getting a personal coach. Don't forget that. Okay. Thank you. Thanks for spending your time with us. And don't forget to use my code VRAW10 during subscription. And hit the bell icon for getting the notifications. So don't forget to subscribe us. Please give your valuable comments on YouTube to strengthen ourselves and to motivate us. And one more, join our Telegram group for getting the latest updates on our upcoming videos. Okay, don't forget these things. Now, once again, I'm welcoming you all to this beautiful online learning platform. Thank you very much.